So now, good afternoon, everyone, and welcome to this lecture. This is lecture number 16 in rolling, and we are very close to finishing this. Maybe this may be the last lecture, as you just saw. In the last lecture, we were discussing cases of accelerated pure rolling, and we saw the case when what are the things that you must remember in pure rolling? The velocity of the point of contact with respect to the surface has to be zero, no slipping. The friction is static in nature, the magnitude is not known. Work done by the static friction is zero. You can apply Lockme. Work energy theorem can always be applied. You also saw what would be the direction of friction, and it depends on where that force is applied. X is greater than k square by r. Friction is same as the force. If the force is forward, friction is forward. If the force is backward, friction is backward. If x is less, then you just have to remember one. If you can remember one, the rest of them will come automatically. If x is k square by r, then the value of friction is zero. You can have zero friction and still rolling. And then we had seen some special cases in which the friction is always backwards. So you remember these cases when the friction was always backwards?
Yes, sir.
If you apply force at the center of mass or below the center of mass, friction has to be backwards because no one can else make it to roll. Now what we are going to do is see some examples where you can find out what would be the direction of friction, and accordingly you can answer some question. So let me start with this one. So let us say that this is a ring. Let us say that we have a body which can obviously roll, and friction is sufficient for rolling. Remember, friction has to be sufficient for it to allow rolling, and we apply force at a distance x from the center of mass. As you can see, the center of mass of this body is here, and let us say the value of this x is r by 2, where r is the radius of this block, of this body. Now you have to find out the direction of friction. It is a rough surface, as I have told you. It's a rough surface, as I have told you. You have to find out the direction of friction in four cases. What are the four cases? Case number one, this is a ring. What is the direction of friction there? Number two, this is a disc. Then what is the direction of friction? Number three, it is a sphere. Then what is the direction of ring? Number four, it is a hollow sphere, or I call it a spherical shell. Then what would be the direction of static friction? Remember, whenever this is in pure rolling, it's given that this block or this body has to be in pure rolling and friction is sufficient to allow pure rolling. In that condition, you have to tell me if x is r by 2, what would be the direction of friction in these four cases? And you already know what you are supposed to know about this question. So here you go. You have 2 minutes to give me the answer. Yes, do we have anything that looks like an answer? Well, I have an answer. Great. So, what is the answer? Yes.
Sir, first, sir,
Yes.
sir, first for ring it is backwards, sir.
For ring, it is backwards. How did you get for ring, it is backwards? You
Second,
must also give a reason. For ring, it is backwards. Why?
less than x is less than k square by r, sir. So as
So,
it's
for
opposite.
ring, let us first find out the value of x is same for all. X is r by 2. The radius of gyration, remember, radius of gyration is about the center of mass. Okay, the radius of gyration, k square. What is k square?
R,
It is
r
r
square.
square, right?
Yes, sir.
And in this case, x is smaller than k square by r. Either you can remember it in this form or you can remember it in this form, x into r is smaller than k square. You can remember it in any form. So here, x into r, here x into r is r square by 2 and k square is r square. So this condition is met. X into r or x is less than k square by r. X is less than k square by r. You go back and you see x is less than k square by r. So this yellow condition is fulfilled. So friction has to be in the opposite direction. Well done. That tells me that we can understand the direction of friction here. The direction of friction here in this case is going to be backwards. Well done. Now, let us go for the disk.
Sir,
X
for disk
is r
fs
by
is 0,
2.
sir.
X is r by 2. And your k
K
square
square
is
is
also
r
r
by.
square by 2.
Yes, sir.
So x into r here is equal to k square. That means the static friction is 0. Actually, we don't require friction for this rotation. So here the value of friction, static friction is 0. So this body can have an accelerated rolling without even friction. Let us go on to this sphere thing. X is again r by 2, but k square is 2 by 5 r square. 2 by 5 r square and k into r is your r square by 2. Which is greater? Here x into r is greater than k square. Yes or no?
Yes, sir.
So what will be the direction of friction here? The direction of friction here would be forward. Do we understand this? Yes or no?
Yes, sir.
Yes or
Yes, sir.
no? Well done. Then comes the last case, the case of the hollow sphere. X is already r by 2. Here k square is 2 by 3 r square. And we get the condition that xr is less than k square. So friction should be in the opposite direction. Here in this case, the friction is backwards. Do we understand this? Yes
Yes,
or
sir.
no? No, yes. Now from here, I can make a variety of questions. If it is a ring and apply force on the top of the ring, listen to my question carefully. If it is a ring and apply force at the top of the ring, what will be the direction of friction? If it is a ring and apply force at the top of the ring, what is the direction of friction?
0, sir.
0, sir, because here k into x, sorry, r into x will be equal to k square. If it is a sphere and I apply force at a distance of 2 by 5 r from the center of the sphere, then again friction would be 0. So it depends on where I am applying force. Do we understand this?
Yes, sir.
Now this is the last part. of rolling that you have to understand. Remember, we only know the direction of friction. We do not know the magnitude of friction because it is the case of static friction. Now, since we know the direction of friction, now you can write all the steps point by point, how you can solve the most difficult problem that can come in this particular topic. So these are the steps, and again all these steps, they come automatically. So this is the first, this is the steps that you must follow to solve any problem. Since we are done with everything, steps. Step number 1 would be what? Draw FBD. Do we understand this? You have to
Yes,
draw
sir.
the free body diagram. Number 2, if static friction is there, that means it is a case of pure rolling. Static friction is only coming when there is pure rolling. If there is not pure rolling, then friction is kinetic and we already know what to do. Okay, if static friction is coming, find the direction of static friction. You know how to find out the direction of static friction, yes or no?
Yes, sir.
Number 3, if Fk is there, you will already know the direction of kinetic friction, yes or no? Because then the body would be slipping, yes or no?
Yes, sir.
If Fk is there, you know the direction of static friction, you know the direction of kinetic friction. You also know that this Fk will be equal to mu k into n. Yes or no? No or yes?
Yes, sir.
Number 4, you can apply torque about the center of mass is equal to I about the center of mass into alpha about the center of mass. Yes or no?
Yes, sir.
You can write F, net F on the body will be equal to m into acceleration of the center of mass. Yes or no?
Yes, sir.
For other bodies, there might be other bodies as well. For other bodies, you can apply F net is equal to their mass into their acceleration. Do we understand this? Yes or no? For
Yes,
other
sir.
bodies might not be rotating. For rotating body, you have to apply both the equation. For translating body, you need to apply only F net is equal to m. Do we understand this? Yes or no? This is going above and saying bye bye. Okay. Now apply the conditions for no slipping. Do we remember those conditions of no slipping?
Yes, sir.
That no slipping between the surfaces, this is equal to this is equal to this. Remember that?
Yes, sir.
Solve equations and get your answer. This is how you will do it if you want to do it by dynamics. Else you can also use one of the other methods. The other methods is, so I will write it in a different color, 7 number. Other methods you can apply. To solve questions you can apply work energy theorem. Do you understand work energy theorem?
Yes, sir.
Work done by all forces will be equal to change in kinetic energy. This can always be applied no matter what you want. Do we understand this?
Yes, sir.
Then if the body is in pure rolling, if pure rolling, if pure rolling, you can apply Lockme. Do we understand this?
Yes, sir.
You can also do it by applying this. for slipping and rolling questions. You understand that slipping and rolling question, the body was first slipping and then it starts to roll. Do you remember those questions?
Yes, sir.
Where we had found out when will it start. You can also apply locam. Do we understand locam with the type of question that we had done? When I had given a ball spin and the ball started to go, you can do the question straight away by locam. You can also do them by the original method, but you can also do them by locam. Quickly you can get your answers. Do we remember those questions or they have gone above and saying bye bye? Huh?
We do remember, sir.
Okay, then that is all you need to remember. Nothing else is left for you to remember. Now, the only thing that is left for you to understand and remember is to solve a couple of questions and then we are good to go. Let me see which question should come first. So, I'll start with this one. Remember, if you can do this one, that means you can do any question that can come. This is the question. A force F acts tangentially at the highest point of a sphere. Whenever it says sphere, sphere is always solid. Of mass m kept on a rough horizontal surface, friction is sufficient to do stuff. If the sphere rolls without slipping, find the acceleration c of the center of mass. Point A, point B, you may not find, and you will find out the value of alpha. So you may not find this. You can also find this, but that's not required. You have to find the acceleration of the center of mass, alpha, and the value of Fs, and obviously the direction of Fs. Direction is also there. You have 2 minutes to get this answer. Can you do it or shall I help?
No, sir, we are doing so.
Good. Okay, let me do it for you. First of all, let us draw the free body diagram of this. The weight is mg. It's a case of pure rolling, so the friction has to be static in nature.
Yes, sir.
First of all, you have to find out the direction of static friction. The value of x is r. A square is 2 by 5 r. So what is the direction of static friction?
Same as F.
Same as f. That means static friction would also be forward Fs. Now, how is this body going to move? There is only one way this body is going to move. The acceleration of the center of mass would be like this. And it is in pure rolling, so alpha should be like this. Yes or no?
Yes, sir.
Then just write the equation. You can write the equation, the translator equation, F plus static friction Fs is m. Mass is not given. You can take the mass as m and radius as r. Anyways, you will not require mass unless until you find out the value of Fs. Mass into acceleration. Then you find out the torque equation. Capital F is like this. It will try to rotate it this way. Static friction is like this. It will try to rotate it this way. What is the torque about the center of mass? One torque is like here, one torque is like this. So what is the net torque? What is the net torque? F minus Fs into R. F is going to create torque like this. Fs is going to create torque like this, but it is rotating like this. So that must be equal to I alpha 2 by 5 m r square into alpha. We have two equations, but we have three unknowns, so we need one more equation. From where will you get this third equation? From that no slipping condition.
Yes, sir.
So what is the equation I will get from that no slipping condition? The acceleration of the point of contact in the tangential direction has to be 0. Yes or no?
Yes, sir.
From there you will get the third equation. A will be equal to alpha r. Yes or no?
Yes, sir.
These three equations can be simultaneously solved and you will get the value of A and alpha. I'll give you 2 minutes to find out the value of A and alpha. Well, you can't take so much of time to solve this simple
1 minute,
equation.
sir. 1 minute.
Can't take so much of time, beta. Can't take so much of time to solve this equation. I've already told you how to do this. I've already told you how to do this. Multiply this equation by r. Alpha into r becomes a. Then add the two equation. Take r on this side. You can eliminate fs and you can get the value of a. How much is the value of a you are getting?
10f by 7m, sir.
That is correct. Acceleration is 10f by 7m. Once you get the value of a, you will get the value of alpha. 10f by 7mr. Once you get the value of these two, no one asked you what the value of static friction, but you can put them in the equation and get the value of static friction. Do we understand this? Yes or no?
Yes, sir.
Now solve the same question. In this case, now this is a ring. This is a ring. Ring of mass m, radius r. Solve the same question as a ring. You have 2 minutes to do it. Can I help you? Should I help you or you will be able to do this? 2 minutes you have. Tell me, how did you get it? In this case, what is the direct? Oh, first of all, let me draw the free body diagram. This is mg. What is the direction of static friction here? I can't hear you. What is the direction of static friction here? Eh? Static friction is zero. There is no need for static friction here. So, you can write the equation. First equation, static friction is zero. You can write the first equation. F is equal to ma. And as soon as you write the first equation, you get acceleration as F by m. You don't have to write any other equation, actually. You get the answer from the first equation. Even if you write the equation for torque, torque is created by this body. F into R is equal to I alpha m r square into alpha. And if you write the equation of slipping, A will be equal to alpha r. No matter how you solve, no matter which equation you solve, you will get the same result. Acceleration is F by m. So when the static friction becomes zero, the question becomes very, very simple. Do we understand this? See, it was so simple. So because of the geometry of the diagram, the question becomes so simple in case of ring. Now we move on to one more last one on this. And Let me solve everything. So here the value of x is given as r by 2. This is a hollow sphere, mass m, radius r, and this is a hollow sphere. So you have all three types of questions, so that you can feel confident that you know everything that you need to know about this. I'll give you 2 minutes to solve this. Do we have the answers? Yes or no? No, yes.
Yes, sir. 6x.
Oh, okay. I don't know the answers. Let us solve it and get it. The first step
Sir,
is
we got it, sir.
the first. I don't know the answer now, but the first step is getting the value of drawing the free body diagram, mg. Now we have to find out the direction of friction. What will be the direction of friction?
Opposite to F, sir.
Means backwards. Yes or no?
Yes, sir.
Fs would be backwards. As soon as we get this, we can move ahead. We can write the first equation of the force. Let me first draw the acceleration a and draw the angular acceleration alpha, because it has to rotate like this. There is no other way it can rotate. The first equation, what is the first equation? Tell me the first equation.
F minus F is equal to mg, sir.
mg?
ma, sir.
Ma, that is a equation of force. What is the equation of torque? This is trying to rotate it like this. This is trying to rotate it like this. Both are adding up.
Sir, F plus Fs into R equals to ICM into alpha, sir.
That is wrong. because f is not at the top. F is at a distance of r by 2. So it is f into r by 2 plus fs into r. Small mistake. The previous question, it was at the top, therefore it was multiplied by r. Do we understand this?
Yes, sir. Yes.
That should be equal to I alpha I is 2 by 3 mr square into alpha. Yes or no? And then the last equation is a is equal to alpha. There is no other motion. Now you can easily solve them and get the value of let me write it in a different color and get the value of a and alpha. Now can you tell me what is the value of a that you are getting?
9f by 10m, sir.
Pakka?
Yes, sir.
9f by 10m. So congratulations. You can now do the last problem, which has, I think, which we tried before also, but then we got caught somewhere. But now we will not get caught. And this is the problem that is coming. Everyone understood this? Same concept, nothing different you have to do.
Yes, sir. Yes, sir.
Okay, then. The problem comes. Problem is always there. You have to find a solution to any problem. Problems will keep on coming in life. So this is the problem, my dear friend. Take a deep breath. And I know you can do this because there is nothing that you should know and I have not told you about this problem. 2 minutes you have to show me your talents. A block of mass small m is attached to one end of a light cord which passes over an ideal pulley. At the other end, it is wrapped around a cylinder of mass m which can roll without slipping on a horizontal plane. What is the extension of the block? Whenever someone says cylinder, it has to be a solid cylinder. Cylinder cannot be liquid. What is the frictional force on the cylinder? You have 2 minutes to solve it. Any hope of getting answers?
1 minute.
1 minute I can wait. Not a problem for me. So note down this table. Remember these small things, because normally what happens is we miss these small things in solving some what you call difficult questions. We miss these questions, so that should not happen. So let me check whether you have understood this with the help of this question. And here comes the question. A disk and a ring of same mass are rolling, and if their kinetic energies are equal, whenever they say kinetic energy, they mean the total kinetic energy are equal. Find the ratio of their velocities. I'll give you 1 minute to do this.
Sir, it is D, sir.
I have an answer. It is D, sir. Answer is A, sir. So, what will be the kinetic energy of the disk? Half into m into velocity of disk square into 1 plus, oops, color has changed, into 1 plus k square by r square. K for k square by r square for a disk is half. So when I put the value half, I'll get 3 by 4 m into vd square. Yes or no?
Yes, sir.
Kinetic energy of the ring, half m, velocity of ring square, 1 plus. Here also k square by r square. The easiest way to remember this. Here k square by r square is 1. So if I do this, I will get mv into ring square velocity. Yes or no?
Yes, sir.
We can now find the ratio of their velocities. Yes or no?
Yes, sir.
What will you get? Velocity of disk divided by velocity of the ring.
Under root 4 by 3, sir.
Root over 4 by 3. Yes or no?
Yes, sir.
You have to be careful while you are doing this question. What is the point of doing so difficult question and then falling in a question which was very, very simple? So remember, that is why I am doing this question. Comes the next one. And I hope you can do this one. A ring, a solid sphere, and a thin disk of different masses rotate. They are only rotating. Rotate with the same kinetic energy. Equal torques are applied to stop them, which will make the least number of rotations before coming to rest. These are the type of question that, if we are not careful, may lead to mistakes. You have 2 minutes to give me the answer for this. Yes, my dear friends. Any answer? Anything that looks like an answer, sounds like one, feels like one? Huh? How are you going to do this? Now, the kinetic energy of each body is same. Now, work done by that torque should be equal to change in kinetic energy. They all have to stop, so change in kinetic energy is same. Now, that work done by that torque is also equal to tau multiplied by theta, where theta is the angle that they have turned. Yes or no? So the angle theta that they turn will be their kinetic energy divided by tau. The torque that is applied. The kinetic energy of the bodies which are rotating are same and they are going to stop. So change in kinetic energy is also same. The torque applied on all the bodies are same. So what about the angle of the bodies that they will rotate?
Same, sir.
Remember these type of questions, because if this type of question come, you should not be found wanting. That takes us to the last topic of this. And again, you will have to remember a lot of things. In this, and these are the questions that are coming in these days, and the heading is rolling down an inclined plane. So you will have a body which would be rolling down an inclined plane. It would be rolling down an inclined plane, no other force acting on it. It would be pure rolling down an inclined plane, no other force apart from gravity, and obviously friction would be sufficient for it to roll down. This will be the scenario given. Height h might be given to you, or the length s might be given to you, or angle theta might be given to you. Remember, in all of these cases, whatever be the type of body, the friction would be static in nature, and you can know that it will be applied in the backward direction. Yes or no?
Yes.
Now remember, here you can apply law of conservation of mechanical energy. Yes or no? Because friction is static in nature. Do we understand this? Yes or no? No or yes? Yes or no? No or yes?
Yes, sir.
So you can straight away apply this. This is the first thing that you must remember. You can apply law of conservation of energy. So you can get this equation. This is how you can solve one or many of the questions. Now I will just give you a table of what all questions are asked and what are their answers. The first question that is normally asked is what is the velocity with which it reaches the ground. So this is the velocity with which it reaches the ground. Sometimes they might also ask you the value of angular velocity when it reaches ground. Remember angular velocity. If they ask you the angular velocity omega, that would be nothing but this v by r. Do we understand this? Yes or no?
Yes, sir.
Then they might ask you the acceleration with which it reaches the ground, the acceleration with which it reaches the ground. I hope you have drawn the diagram. This is the acceleration with which it reaches the ground. This is a full proof of this. You don't have to remember the proof. What you have to remember in this thing is the value of v is this, the value of omega is this, and the acceleration with which it reaches the ground is this. Do we understand this? Yes or no? Do we understand this? Yes or no?
Yes, sir.
Have you noted it down, bacha?
Yes, sir.
Everyone? Everyone has noted this down? Then
Yes,
the
sir.
next thing they might also ask you what is the time it takes to come down. This is the formula for time it takes to come down. Nothing v is equal to u plus at has been put, and you got this answer. If you can remember this, it is very tough to remember, but if you can remember it, it will be very helpful. Do we understand this? Yes or no? No or yes?
Yes, sir.
Then number 4, they might ask you the value of static friction. In general case, the static friction into sine theta divided by 1 plus, up till now everywhere you have got k square by r square, but in the case of static friction you have r square by k square. And number 5, remember that this static friction will always be less than or equal to mu s into mg into cos theta, which is mu s into n. So from here you can find out what is the minimum value of friction required, or mu s required. Mu s should be greater than or equal to tan theta upon 1 plus r square by k square. Do we understand this? Everything has been given, completely solved, completely solved. Nothing you have to do, just use the values and get the answer. Do we understand this?
Yes, sir.
Have you noted it down, bacha?
Yes, sir.
Everyone. Okay, I'll just start it again. I think something got stuck. Have you noted down that, bacha?
Yes, sir.
Can you see that screen now? So, this is again a recap of what we have studied till now. Till now, everything that we have studied, right from first class, from Newton laws of motion till here, what we have studied in one column. If the body is coming under pure rolling, what is the velocity, what is the acceleration, and what is the time in one thing. If it is in pure sliding, Newton laws of motion, these are the answers for Newton laws of motion. Pure sliding, body just moving like this, and it is falling under gravity. Sine theta becomes equal to 1, nothing else. And we have these answers for this body. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye
Understood.
bye? Have you noted it down?
1 minute.
Let me know once you're done.
Yes. Done, sir.
Everyone has got this? Yes or no? Okay. This is again different bodies. Their k square by r square values and the values of acceleration, velocity, time of the descent. You can also make one column for frictional force, which is not normally asked, but you can make the column and keep them in your safe deposit. I'll give you 2 minutes to do this.
Done, sir.
Everyone done, sir?
Yes, sir.
Okay. That takes us to a very simple question. A couple of questions just to reiterate the fact that these are the type of question that can come. So this is the question. A solid cylinder. Cylinder is always solid of mass m and radius r. Rolls without slipping along an inclined plane of length L and height h. What is the speed of the center of mass? And it comes down. I'll give you 2 minutes. Yes, bacha. Got the answer? So much time. That means you don't remember the formula. That is not good. If you write it, you must remember it. Else, what is the use?
Sir, under root 4GH by 3, sir.
Under root 4gh by 3. You should have done it in little bit less time. Anyways, I will give you that. Under root 4 by 3gh. I don't need to explain it. You just need to put the formula of x velocity, get the answer, and stay happy. This comes the next one. Do it fatafat. A sphere. Sphere is always solid. Rolls down an inclined plane of inclination theta. What is the acceleration as the sphere reaches the bottom? The bottom, the bottom, the bottom. Yes, my dear friend. Yes, my dear friend. What is the answer for this one?
Sir, A, sir.
A, sir. You just have to apply the formula. Which formula you need to apply? Acceleration is G sine theta upon 1 plus k square by r square. Yes or no?
Yes, sir.
And you will get the answer as option A. Well done. You must remember all these things. The more you remember, the better you are. Next one, do it fatafat. A solid sphere and disk of same mass and radius start rolling down a rough inclined plane from the same height. The ratio of time taken in the two cases is. Yes, my dear friends.
1 minute.
1 minute.
Sir, option D, sir.
Option D, sir. 14 is to 15. That is correct, sir. Anyone knows how to do this? Time of descent. You will have to be quick. Time of descent, the formula of time of descent. I don't remember it. I think it is 1 by sine theta.
Under root 2h by g into 1 plus k
Under
square by
root
r square.
2h by g into 1 plus k square by r square. So proportional to it is basically proportional to root of under root of 1 plus k square by r square. Yes or no? You
Yes,
just
sir.
find the ratio of root of 1 by k square plus r square and you end up with your result. Well done. Well, all is well that ends well. This is the final call on the chapter. The name of the chapter was rotation.
Rotation.
We are done with rotation once and for all. The more the practice you do in these type of question, remember the question that we did of pure rolling, that question can only come. The question are, it will take some time for you to solve it. That question can only come in a JEE advance. In a JEE mains, you can only get these type of questions. I've covered everything that was possible from my side to cover. I don't think there could be a question which comes out of this territory. In any case, after your JEE mains, I will take some question for JEE advance specifically for that if JEE advance is a bit tricky. So that's it from my end for rotation. Bye bye rotation. And in next class, we'll start with the easier one, gravitation. So we'll finish gravitation and then we'll move on to waves and all that. Take care. God bless all of you. Bye bye.
Have a good day, sir.
Same to you. Bye bye.